Okay, so today we're going to be practicing rational functions that have holes in the graph. Okay, so we are going to start with first looking at our function. So I have them in factored form, and you can see right here that I have a common factor in the numerator and the denominator. This is what causes a hole. So I cross those out and I use that value, -5, and that's where my hole is going to be. Then I rewrite my equation without it, and I use this equation without the common factors to find the information for the rest of my rational function. Okay, so again, the top gives me my x-intercepts, so we have one at 6, 0. The bottom gives me my vertical asymptotes. My powers are the same on top and the bottom, so we use the coefficients. So the horizontal asymptote is at 1. We plug in 0 and we get -2 for our y-intercept. Now for the hole, to find where the hole is, we plug in f of -5. When you plug in f of -5, you get -5 minus 6 over -5 plus 3, which will give you -11 over -2, which is positive 11 over 2. Okay, now we go along with graphing all of our information. So -3 is where my vertical is, horizontal at 1, x-intercept at positive 6, 0, y-intercept at 0, -2, and the hole is at -5, and 11 over 2 is 5.5. So right here at 5.5, that's where our hole is. So I literally draw an open circle to represent the hole. And now we're back to our normal graphing of rational functions. Since on the left side and the right side I have two pieces, since I have my hole here and I have no x-intercept on the left, I know that it's going to come down like this and look like that. On the right side, I know these 2 points connect and it crosses my x-axis, so my right side looks like that. Okay, the next one. Again, the first thing we're going to do, cross out our common factors. So we start with where the hole is. Well, the hole is at 0 when x is 0. Rewrite, so x plus 4 over x plus 6. Now we find the rest of our information. Vertical asymptote at -6, x-intercept at -4. My horizontal asymptote again is at y equals 1. The powers are the same, we use the coefficient. My y-intercept, plug in 0. When I plug in 0, I get 4 over 6, or 2/3. That's also going to be my hole, because my hole is at 0, my y-intercept. So my y-intercept is a hole. So absolutely, because I was supposed to have a vertical asymptote at 0, but that's where my hole is now. So I still have my vertical asymptote here at -6. My horizontal one is at 1. X-intercept is at -4. And my hole is at 0, 2/3. So right there, 0, 2/3. So we graph our two pieces. Now the right side is going to be the easiest because I have this x-intercept and this hole, so these two connect like that. So there's this piece and it crosses and follows this down. Since on the left there's no x-intercept, we know that my left side looks like this. And there's our rational function. Okay. Now, the next one, we're going to do the same thing. We start off by seeing, do we have any common factors? And yes, we do. x plus 4, x plus 4, which means we start with this whole at negative 4. We rewrite, so what we're left with is 4x, x plus 7 over x minus 7 times x plus 5. So the numerator gives us our x-intercepts. So at 0, 0, which means my y-intercept is 0, 0, and at negative 7, 0. The bottom gives me my vertical, so x equals 7, x equals negative 5. Powers are equal, so we use the coefficients, so y equals 4 over 1, which is 4. And then the last thing we do is we plug in negative 4 into my function to find the whole. When you plug in negative 4, you're going to get negative 16 times 3 over negative 11 times 1, which is 48 over 11, which is approximately 4.4. So this is 48 over 11. Okay, so let's graph our information. So verticals are at negative 5, positive 7, horizontal is at 4, x-intercepts 0, 0, negative 7, 0. Our whole is at negative 4, 4.4. 1, 2, 3, 4. So basically our whole is right there. Okay, so now that all of our information is graphed, we're going to use it to graph our three pieces. And we have three pieces because we have those two vertical asymptotes. So let's use this x-intercept on the left. Since I have an x-intercept here, I know that my function is going to come up here, cross here, and follow that horizontal asymptote out. Conversely, on the right, there's no x-intercept, so it can't come up, so it has to come down and follow out that way because it can't cross the x-axis. Now here in the middle, I have the whole, which means it has to come through here, cross, come down this side, and on the other side it's going to follow that up on the left. So these holes, you got a little extra work to find them by plugging them into the function and finding their y value, but often give us more information to graph with. Okay, if we didn't have this hole at negative 4, 48 over 11, then we would have had to plug in a value anyway to find out what was going on in the middle. But since that hole is there, we didn't have to do that. Okay, and the last one, following the same steps. So start by, do we have a common factor in the numerator and denominator? Why, yes. Yes, we do. So that means that our whole is going to be at negative 7 because it's wherever this vertical asymptote would have been. All right, so we rewrite what we have left. So x minus 9 times x minus 5 over x minus 7, x plus 3. So our x-intercepts are going to be at 9, 0 and 5, 0. Vertical asymptotes are at positive 7 and negative 3. The horizontal, since the powers are the same, y equals 1. Your y-intercept, plug in 0, which means negative 5 times negative 9 is positive 45 over negative 7 times positive 3, which is negative 21. So 45 over negative 21. Now, our whole, we have to plug in negative 7. When you plug in negative 7, you're going to get negative 16 times negative 12 over negative 14 times negative 4, which is big numbers, which is positive 192 over 56, which is approximately 3.43. So, or if you reduce it, it's 3 and 24 over 56. Okay? All right, so let's graph our information. Same thing we've been doing. Should be pros at this by now. 7, -3, horizontal at 1, x-intercepts at +5, 9, y-intercept at 0, -45 over 21, which is basically 2.2, 2.3. So there's my y-intercept. And then our hole, which is at -7, 1, 2, 3, 3.43. And again, if we didn't have that hole there, on the left side, we would have had to plug in a point. But since on the left side we have that hole above and no x-axis or x-intercept right here on the left, we know it's got to come down through where the hole is and follow the asymptote out. On the right side, we have an x-intercept there, so we know it's down here where it comes up, crosses the x-axis, and follows the asymptote. And in the middle, we have 2 points, the y-intercept and the x-intercept. So we know it comes down here, crosses through, crosses the y-axis, and goes down like that. And that is basically how you graph rational functions with holes in them. So it's basically not any different than what we've been doing. We just add in having to find that coordinate of where the hole is supposed to be.